This graph depicts current statistics on opioid-related deaths that have occurred in Massachusetts. As you can see, drugs like fentanyl have higher death rates, but drugs like heroin have decreasing death rates. Why? This could be due to the increased use in naloxone to save people during overdoses. Let's take a look at the molecular structure and facts about common opioids. This is morphine. It's a common painkiller used. It can be very addictive in high doses and can cause respiratory arrest. This is heroin. Heroin has the same structure as morphine when it attaches to the opioid receptor. It is one of the most commonly used opioids. This is fentanyl. Fentanyl is a newer, stronger opioid and is commonly mixed into different opioids, causing a greater increase in overdose deaths. This is naloxone. It is not an opioid. It is an antagonist, meaning it can block opioids from binding. It is typically administered intranasally while someone is experiencing an overdose.
We'll be looking at a case study where someone overdoses on heroin and is saved by naloxone. Naloxone will be represented as this green molecule, and the heroin will be represented as this red molecule. This is Jimmy. Jimmy is a heroin addict and is about to overdose on heroin. This is Jimmy's brain. Let's take a look inside. When heroin is injected, it can reach the brain and cause adverse effects, including the inability to breathe. Since Jimmy can't breathe, naloxone is administered to displace the heroin molecules, saving his life. But how does this work?
This is a model of the opioid receptor with heroin, the red molecule, currently attached. As you can see, the naloxone, the green molecule, cannot bind to the receptor while heroin is bound. What happens is, eventually the heroin disconnects from the receptor, which allows the naloxone molecule to swoop in and bind to the receptor site, blocking other heroin molecules from binding.